Hello and welcome back to the Sleepy Geographer. Tonight, we're exploring one of the oldest questions our planet has ever asked. Where did all of Earth's water actually come from? Not just the water in a single river or ocean, but every drop that has ever fallen as rain, every glacier, every lake, every sea, and even the water quietly resting inside you tonight. Before we begin, let me know in the comments where you're listening from and what time it is for you. I always enjoy seeing people from so many different corners of the world joining these peaceful journeys. Now, get comfortable, settle in, and let's begin. Right now, wherever you are, there is water nearby. Maybe it's a glass on the nightstand, catching a thin line of light from somewhere in the room. Maybe it's only in the air itself, an invisible dampness you'd never think to notice unless someone mentioned it, the way I just did. Maybe it's simply within you, in the fluid that fills your cells and moves through your veins and keeps every part of you working without asking for your attention. That water has been many other things before it was this. It was cloud. It was ocean. It was ice sitting on top of a mountain for 10,000 years without moving. It was rain falling on a forest long before there were people to walk beneath the trees. Trace it back far enough, and it was something stranger still. Trapped inside a comet drifting through the dark between the stars, or locked inside a piece of rock deep within a planet that hadn't finished forming yet. We're going to follow that water back tonight, all the way to the very beginning, to a version of Earth that had no water on it whatsoever. A hot, hard, restless place, spinning through space, with nothing on its surface but stone and heat and the dim light of a much younger sun. It's a strange thing to picture, a dry Earth. We think of this planet as the water planet. From far enough away, seen from space, it's mostly blue. But that blue took time to arrive. For a long while, longer than anything alive today could measure in a single breath. There was no ocean here, no rain, no ice at the poles, nothing but rock and heat and the long, slow work of a planet cooling down. That's where tonight's story begins. Picture the Earth 4.5 billion years ago, not as a place yet, not really, more like an event still in progress. A ball of rock and metal, freshly gathered out of the same swirling disk of dust and debris that built the sun and every other planet circling it. The whole thing is still glowing. Not glowing the way a coal glows at the edge of a fire, but glowing the way metal glows when it has just been poured from a furnace, orange and restless and far too hot to hold any shape for long. There is no ocean here. There is no sky the way you would recognize a sky. There is barely a surface at all, in the sense of something solid enough to stand on. The outer layer of this new planet is closer to liquid rock than to stone. It moves the way thick liquid moves, folding over itself, releasing heat upward in slow, rolling waves that would blind you if there were an eye anywhere nearby to see them. The heat comes from everywhere at once, from the leftover energy of the planet's own formation, all that dust and rock falling together and striking one another hard enough to melt, from the decay of elements buried deep inside, quietly releasing their own warmth the way they will keep doing for billions of years afterward. And from something else, too. A rain of debris still falling from space, smaller pieces of the same disk that made the planet, striking the surface again and again, each impact adding its own burst of heat to a world that already has more heat than it knows what to do with. If you could stand somewhere nearby and watch this world at a safe distance, it would look less like a planet and more like an open wound in space. A sphere of dull orange light, cracked in places to show something brighter and hotter underneath, drifting through the dark with no ocean, no cloud, no green anywhere on it. Nothing that looks, in any way, like home. The sun overhead is fainter than the one you know, Stars form in stages, and young stars burn with less light than they will later in their lives, so even the daylight on this early Earth, if you can call it daylight, with no clear atmosphere to carry it, would feel thin and pale compared to what you're used to. There is no sound in the way you understand sound, no air to carry it, but if there were, this would be a world of low groans and deep cracking, the sound of a surface still deciding how to cool. Water, if it exists anywhere on this scene at all, exists only as invisible traces. A few molecules bound up chemically inside minerals, locked so tightly into the structure of the rock that they behave more like part of the stone itself than like water at all. Nothing free, nothing liquid, nothing that could gather into a puddle, let alone a sea. This is the planet before the story we usually tell about it, before the blue marble, before anything recognizable as the Earth in any photograph you've ever seen. Just heat and rock and the patient work of a world beginning to cool. Nearby, in this same crowded stretch of young space, other worlds are taking shape too. A smaller red planet, forming further out where the sun's warmth reaches more thinly. A pair of giant worlds further out still, gathering gas around themselves at a scale that dwarfs anything closer in. And countless smaller fragments, pieces that never quite gathered into a planet at all, left to drift and collide and occasionally fall inward toward the warmer worlds nearer the center. Every one of these bodies formed from the same original disk of material, and every one of them carries some version of this same early story. A hot beginning, a long cooling, a slow discovery of whatever it would eventually become. Cooling, on a scale like this, does not happen quickly. It isn't the kind of cooling you notice in an evening, watching the temperature drop as the sun goes down. It's something closer to the way a very large object holds its warmth long after a small one would have gone cold. Think of a huge iron pot taken off a stove, still radiating heat hours later, long after a small cup beside it has gone cool to the touch. Now imagine that pot is an entire planet, and the hours are millions of years. Slowly, the surface begins to lose its glow. The outermost layer, exposed to the cold of space, starts to harden first, not all at once and not evenly. Patches of the surface solidify into a thin, dark crust, like the skin that forms on the surface of a bowl of soup left standing too long. That skin is fragile. Beneath it, the rock is still liquid, still moving, and every so often the crust cracks and the molten rock beneath pushes back up through it, glowing red before cooling again into new stone. This happens again and again. Crust forming, crust breaking, molten rock rising to replace it. A restless surface, still deciding what it wants to be. Given enough time. And here, enough time means something closer to tens of millions of years than anything a human calendar could hold. The crust begins to win. More of the surface stays solid. The patches of glowing rock become smaller and further apart, like the last embers of a fire settling down for the night. The Earth is not cool, not yet, not by any standard you'd recognize, but it has a surface now, a real one, something you could, in principle, stand on if the heat and the poisonous air didn't kill you first. And above that hardening surface, something else is beginning to gather. Gas. As the molten rock cools, it releases the gases that were trapped inside it, the way a bottle of soda releases bubbles when you finally open the cap. These gases rise up from the cooling crust and begin to collect above it, forming the very first version of an atmosphere this planet has ever had. It is nothing like the air you're breathing right now. There is no oxygen in it, none at all, or at most only the faintest possible trace. Instead, there is carbon dioxide and nitrogen and other gases that would be entirely unbreathable to you or to almost anything alive today. There may already be traces of water in this early atmosphere too, floating as vapor rather than falling as rain, released from the same molten rock that is finally beginning to cool and settle. But this is a fragile beginning. This early atmosphere is thin, and the planet beneath it is still enduring one of the most violent periods in its entire history. Because even as the crust solidifies, even as gases gather in a thin shell around the planet, the debris raining down from space has not stopped. Pieces of leftover material, some no larger than pebbles, some as large as small planets in their own right, are still colliding with this young Earth, striking with enough force to melt whole sections of the newly formed crust all over again. Each major impact undoes some of the slow cooling that came before it. Crust reheats, surface reliquefies. The whole process of settling down has to begin once more in the places where the largest impacts strike. It is, in other words, a planet caught in a long argument with itself, cooling in one place, remelting in another, gathering the first traces of an atmosphere while still absorbing blow after blow from space. And through all of it, no water yet gathers on the surface, because there is no surface stable enough or cool enough for water to gather on. Anything that might condense into liquid simply boils away again the moment it touches ground still hot enough to glow. This is Earth without an ocean, Earth without rain, a planet doing the long, unglamorous work of becoming solid enough and cool enough for anything else to happen at all. Somewhere in this scene, if you looked closely enough, you would find the moon. Not the pale, familiar companion that rises over your own rooftop, but something newer and much closer. Most of what became the moon was flung into orbit by one of the largest impacts this young Earth ever endured. A collision so enormous that it reshaped the planet's spin and left behind a glowing ring of debris that gathered itself over time into a second, smaller world. That moon hangs far nearer in the sky than the one you know, close enough that its gravity drags at the loose rock and half-molten surface of the Earth below, pulling at a planet that does not yet have oceans to raise into tides. There is a strange kind of company in that. Two bodies, freshly made from the same violent event, circling each other in a young and mostly empty stretch of space. Neither one yet holding a single drop of the water either will eventually come to hold in vastly different amounts for the rest of their long history together. The moon, in time, will lose almost all of what little it has. The Earth will keep gathering more. But neither of them knows that yet. Right now they are simply two scarred, glowing bodies, turning slowly around each other in the dark, each one still too hot to hold anything as fragile as a sea. Days on this early Earth are shorter than the ones you know, the planet spinning faster than it does now, before the moon's steady pull slows it down across the coming billions of years. A full turn of the planet might take only a handful of hours rather than the 24 you're used to. If there were an observer standing on the surface, they would see this faint, faraway sunrise and set again and again in rapid succession, the sky brightening and dimming almost too quickly to settle into. There is something worth sitting with in this image of an Earth with no water. We think of oceans as something a planet simply has, the way a person simply has a face or a name. But water, on a planet like this one, was never guaranteed. It had to arrive, or had to be made, through processes that took an enormous amount of time to unfold. There was a version of this world, the very same ground beneath whatever city or forest or coastline you might be picturing right now, that had no water on it at all. Not a drop. Not a puddle. Nothing but stone and gas and heat looking for somewhere to go. If you let yourself sit inside that image for a moment, this planet in its earliest form, orange and cracked and utterly dry, it changes the way the ocean feels the next time you picture one. It stops being a given. it becomes something that had to happen. Something that was made slowly out of almost nothing, the same way mountains are built out of falling shells and folding rock over unthinkable stretches of time. Water, it turns out, is not simple. It has a history. And the history of that history, how it first came to be here at all, is something scientists still don't fully agree on, even now, after more than a century of careful looking. That's where we're headed next. Not yet to the answer. First, to the mystery itself. Here is something that might surprise you. For as confidently as people talk about Earth's oceans, the honest scientific answer to where all that water actually came from is still, in places, an open question. Not a mystery in the sense of something no one has looked into. Plenty of very careful people have spent entire careers looking into exactly this. But a mystery in the sense that the evidence, when you follow it closely enough, points in more than one direction at once, and researchers are still working out how those directions fit together. It helps to understand why this is even a hard question in the first place. When our solar system was forming, the region of space close to the young sun was far too hot for water to exist as ice. Any ice that might have formed there would have evaporated instantly in the heat pouring off a newborn star. That means the raw material that built the inner planets. Mercury, Venus, Earth, and Mars should, by most models, have been extremely dry to begin with. The rocky rubble that gathered together to form our planet formed close to the Sun in the warm part of the disk where ice simply couldn't survive. Further out, past a certain distance from the Sun, the story is completely different. Beyond what scientists sometimes call the frost line, the boundary in that early disk where temperatures finally dropped low enough for ice to form and stay frozen. The material drifting through space was thick with it. Icy pebbles, icy boulders, entire small worlds built largely of frozen water mixed with dust and rock. Everything on the far side of that invisible boundary formed cold and wet. Everything on the near side, where Earth was taking shape, formed hot and dry. And yet here we are on a planet where water covers most of the surface. So the question becomes simple to ask, even if it's difficult to answer. If Earth formed from dry material in a warm part of the solar system, where did all of this water come from? There are two broad answers that scientists have spent decades testing against each other, and tonight we're going to sit with both of them, one at a time, without rushing toward a winner. The first answer says the water was here all along, just hidden, not on the surface, but locked inside the rock itself, bound up at a chemical level within minerals that formed as the planet came together. On this view, Earth's oceans didn't arrive from somewhere else. They were released, slowly, from within the planet, as heat and pressure and volcanic activity gradually freed water that had been trapped inside solid rock since the very beginning. Water born from fire, in a sense. Not something added to the Earth, but something drawn out of it. The second answer says that Earth simply didn't have enough water of its own, and that most of what we have today arrived later, carried here from somewhere much colder and much further out in the solar system, past that same frost line. Comets, formed in the deep cold beyond the orbits of the outer planets, are made largely of ice. So are many asteroids from certain regions of the solar system. On this view, over a long stretch of the planet's early history, Earth was struck again and again by icy visitors from far away, and each impact delivered a little more water to a world that otherwise would have stayed dry. Neither of these ideas is a guess pulled out of nowhere. Both are supported by real evidence, gathered slowly and carefully over generations of research. And this is part of what makes the question so interesting rather than so simple. It isn't obviously one or the other. The most likely truth, as we'll see, is some combination of both arriving at different times, through different processes, adding up slowly into the oceans we know today. scientists have a quiet way of testing an idea like this. They look at the water itself closely enough to read a kind of signature inside it. Ordinary water is made of hydrogen and oxygen, but a small fraction of that hydrogen is a slightly heavier version of itself, called deuterium. The ratio between ordinary hydrogen and this heavier form varies depending on where the water formed and how far it travelled before arriving. Comets have their own particular ratio. Certain kinds of asteroid have another. The water inside Earth's rocks has its own signature too. By comparing these ratios carefully, researchers can ask a very specific question of the evidence. Does Earth's water look more like it came from comets, or from asteroids, or from somewhere closer to home altogether? The answers that come back are not always tidy. Some comets, when spacecraft finally travelled close enough to measure their ice directly, turned out to have a ratio quite different from Earth's oceans, different enough that they seem an unlikely main source. Certain asteroids, particularly a rocky, carbon-rich kind found in the outer part of the asteroid belt, match far more closely. It is this kind of patient, careful comparison. Not guesswork, not speculation, but the slow accumulation of small, specific clues gathered from meteorites in museum drawers and from instruments carried across the solar system on spacecraft. That has shaped everything we're about to explore tonight. For now, it's enough to sit with the shape of the question itself. A planet that shouldn't have had much water at all, somehow ending up covered in it. Two very different stories about how that might have happened, both still being tested, both still being refined, as new evidence comes in from meteorites, from comets visited by spacecraft, from tiny mineral grains studied under powerful microscopes in quiet laboratories around the world. Whichever story turns out to be more true, in whatever combination, one thing is already clear. The water we take so completely for granted did not have to exist here. It arrived, or it was released, through processes that took hundreds of millions of years to unfold, on a planet that spent its earliest life as dry, as hostile, and as unrecognizable as any place could be. As that young world continued its slow cooling, the next chapter of its story was already beginning beneath the surface. Hidden deep inside the planet, somewhere in the darkness below, something remarkable had been waiting all along. Somewhere beneath that dark, settling crust, in rock still hot enough to move like something closer to liquid than stone, trace after trace of water sits locked in place, waiting for a kind of pressure it does not yet feel, a kind of heat it has not yet reached the surface to release. It has been there since the beginning, folded into the structure of the minerals themselves, patient in the particular way that stone is patient, asking nothing, offering nothing, simply held. Far above, on the surface of this early world, nothing marks the passage of time except the slow dimming of light where fresh crust cools and the sudden brightening where a new impact tears it open again. There is no wind yet. Not really. Not in any way that could carry sound the way wind carries sound across an ocean or through a forest. There is only this thin, poisonous shell of gas, gathering itself a little more with each passing age, waiting for the surface below to grow calm enough and cool enough to let something new begin. The oceans are still a long way off yet, but the fire that will help build them is already burning, deep beneath that dark and settling crust. That's where we're headed next. Down into the rock itself, to see what happens when a planet learns, for the first time, how to breathe. Deep beneath the settling crust of this young Earth, in rock still hot enough to bend rather than break, water is waiting. Not water in any form you would recognize. Not a drop, not a pool, not even a mist. It exists instead as something closer to a memory locked inside the minerals themselves, hydrogen and oxygen bound so tightly into the crystal structure of the rock that they behave less like a liquid and more like a permanent part of the stone's own chemistry. This is the water that gathered here from the very beginning, folded into the material long before the planet finished forming, carried inward with every grain of dust and every fragment of debris that ever fell together to build this world. It has been sitting there, unmoving, for longer than anything alive today could hold in the mind. But rock, even rock this deep, does not stay perfectly still. And under the right conditions of heat and pressure, it begins to let go of what it has been holding. This is where the first great turning point in the story of Earth's water begins. Not in an ocean, and not falling from the sky, but rising up from within the planet itself, released by fire. To understand how this happens, it helps to picture the inside of the Earth the way you might picture the inside of a sealed jar left standing over a low flame. Deep within the planet, heat continues to build. Some of it left over from the earliest days of formation, some of it created continuously by the slow decay of radioactive elements buried in the rock, quietly producing warmth the way a smouldering ember produces warmth long after the fire around it has gone out. This heat has nowhere to go but up and out, seeking the cooler surface the way warmth always seeks a colder place to travel toward. As that heat rises, it moves through the mantle, the thick shell of rock that lies beneath the crust and makes up the greatest part of the planet's interior. The mantle is solid, in the sense that if you struck it with a hammer, it would behave like stone. But over long stretches of time, under the pressure and heat found at such depth, it flows. Not the way water flows, quick and free, but the way something extraordinarily thick and heavy might flow if given centuries rather than seconds to move. Currents of hot rock rise slowly from deep within the planet. Cooler rock near the surface sinks back down to replace it, a vast, unhurried circulation turning over the interior of the Earth again and again across its whole history. Within this slow-moving rock, the water trapped inside ancient minerals begins to behave differently as it nears the surface, where pressure eases and temperatures shift. Some of the rock, carrying its hidden water along with it, rises close enough to the crust that it begins to partially melt. This melted rock is called magma, and magma is lighter than the solid stone around it. It rises further still, pushing upward through cracks and weaknesses in the crust, carrying with it not only molten rock, but the water that had been locked away inside it since the world began. When that magma finally reaches the surface, whether through a quiet fissure or a violent eruption, it does something the planet has not done before. It breathes. Picture this early Earth from somewhere just above its surface, in the years after the worst of the bombardment has begun to ease, though it has not yet fully stopped. The ground beneath you, where there is ground stable enough to call solid, is dark and cracked, still glowing faintly in places where the newest rock has only just begun to cool. Across this landscape, in scattered clusters and along long, uneven fractures in the crust, volcanoes are erupting. Not the way a volcano erupts in a single dramatic burst you might picture from film or photograph over in a matter of hours. These eruptions stretch on. Some vents simply ooze molten rock in slow, glowing rivers that creep across the ground for days at a time. Others release columns of ash and gas that rise high above the surface, spreading outward in the thin early atmosphere until they settle back down, layer after layer, coating the ground in fine dark powder. And rising from every one of these eruptions, mixed in with the ash, the sulfur, and the other gases pouring out of the deep earth, is water. Released as vapor the moment the pressure of the deep interior gives way to the emptier pressure of the surface, the same way steam rushes out of a kettle the instant you lift the lid. This is the beginning of outgassing, the slow release of gases that have been trapped inside a planet since its formation, escaping upward through volcanic activity across a period of time too long for any single eruption or any single volcano to matter much on its own. What matters is the accumulation, eruption after eruption, vent after vent, across the whole surface of a restless, cooling world, releasing a little more water vapor into the sky with each passing age. If you stood on this planet's dark and broken surface and looked upward, you would see a sky thick with cloud, though cloud is almost too gentle a word for it. This is not the soft, drifting white you're used to. It is heavy and low and coloured by ash and sulphur into shades of yellow and grey and a strange dull orange where the light of the faint young sun manages to filter through. The air itself would be unbreathable, filled with gases that carry a sharp mineral edge, the smell of a world still learning how to hold itself together. And beneath that heavy sky, the ground continues its work. More magma rises. More water escapes, more gas gathers in an atmosphere that grows thicker and stranger with every passing million years. There is a rhythm to this that's worth sitting inside for a moment. Somewhere on this dark surface, a single vent has been active for what would be, by any human measure, an extraordinarily long time. It does not erupt in the way you might picture an eruption, a sudden violent burst followed by stillness. It simply continues. A slow, steady welling of molten rock rising to the surface, spreading outward in thin, glowing sheets that cool at their edges into black, brittle stone almost as soon as they stop moving. Where the freshest rock meets the air, threads of vapor rise continuously, thin and pale against the darker gases surrounding them. If there were any way to listen closely to this scene, you might hear something like a low, steady hiss, the sound of pressure finding release over and over in the same place for centuries at a stretch. Nothing about this single vent looks, in any given moment, like the beginning of an ocean. It looks like exactly what it is: a small release of gas from a much larger and much slower process happening across the whole planet at once. But multiply this scene by thousands, by hundreds of thousands, scattered across every corner of this restless world, active in some places for centuries and in others for entire ages, and the total volume of water vapor entering the atmosphere becomes something else entirely. Not a single dramatic delivery, but a patient, continuous seep. The same way sediment gathers on an ocean floor one grain at a time until, given enough time, a mountain's worth of material has quietly accumulated. The vapor released this way does not stay near the ground for long. It rises, mixing into the thickening atmosphere above, carried by whatever faint winds move through this early sky, spreading far beyond the volcanic fields where it first escaped. In time, this vapor will be part of the same sky covering the entire planet, no longer tied to any single eruption, simply part of the air itself. It is worth pausing here to notice something about this process, because it changes the shape of the story quite a bit from how you might have first imagined it. The oceans of Earth, in this telling, were not simply waiting somewhere out in space to be delivered here, whole and complete, the way a package might arrive at a door. A significant portion of Earth's water, according to this first theory, was inside the planet the entire time, present from its earliest moments, bound so completely into the chemistry of the rock that it took heat and pressure and hundreds of millions of years of volcanic activity to coax it back out again. There is something almost intimate in that idea. The ocean, on this view, is not a visitor. It is something the planet made from what it already had inside itself, the way a seed contains, in some folded and hidden form, everything it will eventually need to become a tree. Scientists have found real evidence to support this idea, gathered not from any single dramatic discovery, but from careful, patient work carried out in laboratories over many decades. When researchers study certain kinds of volcanic rock, formed deep within the earth and only occasionally carried up to the surface through eruptions, they find water locked inside minerals in quantities that surprised many of the geologists who first measured it. Deep within the mantle, at depths far below anything a drill could ever reach directly, there appear to be reservoirs of water-bearing rock holding an amount of hidden water that, by some estimates, could rival or even exceed the entire volume of water in all of Earth's oceans today. Not liquid, held inside solid crystal structures instead, but water all the same, present and accounted for, deep within a planet that looks, from any point on its surface, entirely dry in that particular direction. One remarkable clue comes from tiny minerals trapped inside diamonds formed deep within the Earth. These diamonds preserve fragments of the mantle exactly as they were billions of years ago. When scientists study those trapped minerals, they find water locked inside them, offering one of the clearest pieces of evidence that Earth's deep interior has always held vast amounts of hidden water. This changes the picture of where oceans come from. It suggests the planet did not need to receive all of its water from somewhere else. It may have carried enough within itself from the very beginning, needing only time and heat and the patient work of volcanic activity to slowly bring a portion of that hidden water up to where it could finally become something else. Vapor first, then, eventually, rain. But outgassing alone does not explain everything, and this is where the story becomes more complicated and more interesting. Because even as this early atmosphere thickens with water vapor rising from the Earth's own interior, something else is happening across the wider solar system. Something that has nothing to do with volcanoes at all, and everything to do with what is arriving from somewhere much colder, much farther away, and much older than anything the young Earth has produced on its own. To understand this second part of the story, it helps to step back from the Earth entirely and picture the solar system as a whole in those same early ages. Beyond the orbit of Mars, past the warm inner region where rocky planets formed from dry material close to the Sun, there lies a wide belt of smaller bodies, fragments of rock and metal and ice that never gathered together into a full planet at all. Some of this material sits in a broad ring between Mars and Jupiter, a scattered field of asteroids left over from the earliest days of the solar system's formation. Further out still, beyond the giant planets, an even colder and more distant region holds countless icy bodies, the raw material from which comets are made, drifting slowly at the very edge of the Sun's influence. This outer material formed under conditions entirely different from the ones that shaped Earth. Out here, far from the heat of the young Sun, temperatures were low enough for ice to form and remain stable rather than boiling away. The bodies that gathered in this cold, distant region are rich with frozen water, mixed together with dust and rock and other frozen compounds in proportions that reflect the particular chemistry of wherever in the solar system they happen to form. For most of the solar system's early history, this outer material stayed largely where it was, following orbits that kept it far from the warmer inner planets. But orbits are not perfectly stable things, especially in a solar system as young and as crowded as this one. The gravity of the giant planets, still settling into their own final positions during this early period, tugged and nudged at the surrounding debris, sending some of it drifting inward toward the Sun, toward the warmer worlds where Earth was still cooling from its own violent birth. This is the second theory, then. Not water rising up from within the Earth, but water carried in from somewhere else entirely, delivered across an immense distance by icy visitors that had spent their whole existence, until that point, in the cold and distant edges of the solar system. Picture one of these bodies making its long journey inward. A comet, formed from ice and dust in the frozen outer reaches, following an orbit that has been quietly shifting for a long stretch of time, nudged by the gravity of a giant planet passing somewhere nearby. Slowly, over the course of what would be, for it, an extraordinarily long fall, this comet begins moving inward, past the orbit of the farthest planets, past the wide asteroid belt, drawing closer to the warmth of the inner solar system with every passing circuit. As it approaches the Sun, the ice at its surface begins to change. What was solid and frozen begins to turn directly to vapor in the thin cold of space, releasing a faint trail of gas and dust behind it, the beginning of what will eventually become a visible tail if there were any eye nearby to witness it. But this comet is not headed toward a graceful pass by the Sun. Its path carries it directly toward a young, rocky planet still glowing in places from its own violent formation. The end of that journey is not gentle. There is no soft, wave-like arrival, no quiet mist settling onto the surface the way it might in a kinder version of this story. The comet strikes the Earth's surface with tremendous force, the energy of its long fall converted in an instant into heat and light, and a shockwave that spreads outward across the surrounding landscape. Ice becomes vapor almost immediately. Rock becomes fragments thrown outward from the point of impact. What was, moments before, a quiet traveler through the cold dark of space, becomes, in a single violent moment, part of the Earth itself. Although each impact was violent, together they slowly delivered more water to the young Earth. Not all at once, but across hundreds of millions of years, countless icy bodies added small amounts until the total became enormous. Picture the sky of this early Earth during the busiest stretch of this long bombardment. At night, if the ash and gas thin out enough anywhere to allow a clear view upward, streaks of light would cross the sky with a frequency that has no equivalent in the sky, you know. Not the occasional shooting star that might catch your eye once or twice on a clear night, but a steady procession of them, fragments of rock and ice entering the thin atmosphere and burning briefly before either disintegrating overhead or continuing down to strike the surface somewhere beyond view. Some of these fragments are small enough to burn away entirely before reaching the ground, leaving nothing behind but a brief streak of light and a faint trace of dust drifting down through the atmosphere over the following days. Others are large enough to survive the passage down, striking the surface with enough force to throw rock and dust for great distances in every direction, opening fresh craters into a crust that has barely finished cooling from the last such impact nearby. Over the vastness of this early period, the surface of the Earth would have borne the scars of this bombardment almost everywhere at once, overlapping crater upon crater, the way ripples overlap on the surface of a disturbed pond, each new impact partially erasing the shape of whatever came before it in that same spot. Anywhere you looked, evidence of arrival. Dust that had drifted for who knows how long through the emptiness between the planets, finally coming to rest here on this one world, adding its own small share to a slowly gathering supply. Scientists have looked for ways to test which of these two stories, the fire from within or the ice from without, better explains the water we have today, and the honest answer, as we touched on earlier, is that the evidence points towards some combination of both, though working out the exact proportions has taken decades of careful comparison. One of the clearest tools available for this kind of comparison is the specific ratio we mentioned before, the balance between ordinary hydrogen and its heavier form, deuterium, present in tiny but measurable amounts in every sample of water anyone has ever studied. This ratio functions almost like a fingerprint, varying depending on where in the solar system a particular body of ice or rock originally formed. When spacecraft finally traveled close enough to certain comets to measure this ratio directly, the results surprised many researchers who had expected a closer match to Earth's own water. Several well-studied comets showed a ratio noticeably different from what is found in Earth's oceans, suggesting that at least some kinds of comet, formed in particular regions of the outer solar system, are unlikely to have been the dominant source of the water we have today. Certain kinds of asteroid, on the other hand, particularly a dark, carbon-rich variety found scattered through the outer portion of the asteroid belt, show a ratio much closer to what is measured in seawater here on Earth. This has led many researchers to suspect that asteroids, rather than comets, may have delivered a larger share of Earth's water from beyond its own formation, striking the young planet across that same long bombardment period, carrying with them not ice in any pure, gleaming sense, but water bound up within clay-like minerals, similar in some ways to the water hidden inside Earth's own volcanic rock. This is part of what makes the mystery so layered rather than simple. It isn't a clean choice between fire and ice, between water rising up from inside the Earth and water falling in from outside it. It looks, instead, like both processes were happening at once, across the same vast stretch of early time, each contributing its own share to a total that neither process alone could have produced. Some water was always here, folded into the rock from the very beginning, waiting for heat and pressure to set it free. Some water arrived from elsewhere, carried across the solar system by travelers that had spent unimaginable stretches of time drifting through the cold dark before their long fall finally ended here. There is a certain kind of humility built into this conclusion, one worth sitting with quietly for a moment. The two competing stories that once seemed like rivals, each trying to explain the whole ocean on its own, turn out instead to be partners, each responsible for a portion of something too large for either to have built alone. The full picture only comes into focus when both are held together, the fire and the ice, the water that was always here and the water that had to travel an unthinkable distance to arrive. Picture, for a moment, both of these processes happening together, layered over one another across the same stretch of geological time. Beneath the surface, volcanoes continue their slow work, releasing water vapor from deep within the planet in eruption after eruption, thickening the atmosphere a little more with each passing age. Above and around this same restless world, the last of the solar system's leftover debris continues to fall inward, comet and asteroid alike, striking the surface with enough force to reshape the ground for miles around each impact, and delivering, each time, a further trace of water to a planet already gathering more of it from within. Neither process needs the other to be true for the story to make sense, but together, they explain something that either one alone struggles to account for entirely. A planet with enough water to eventually cover most of its surface, despite having formed from material that, in the beginning, should have been almost entirely dry. The sky above this early Earth, in the ages we're picturing now, holds more moisture in it than it ever has before. Vapor drifting up from 1,000 scattered volcanic vents. Vapor released in an instant wherever a fresh impact tears open the ground and flings ice and rock skyward in the same violent moment. All of it gathering, mixing, thickening a sky that is still far too hot and far too young to let any of that moisture fall back down as rain. Not yet. The ground beneath this thickening sky is still glowing faintly in places. Still hot enough that anything approaching liquid water would simply boil away again the instant it touched stone. The atmosphere holds more water now than it ever has, and still, for a while longer, none of it can rest anywhere at all. But something is changing, slowly, the way everything in this story changes slowly. The surface is losing its heat a little more with every passing age. The impacts, though they have not stopped completely, are growing less frequent, less catastrophic, as the solar system itself settles into calmer, more predictable orbits. And high above the ground, in a sky thick with the vapor of fire and the vapor of ice alike, the conditions are slowly gathering towards something this planet has never experienced before. A sky ready, at last, to let go of what it has been holding. Soon, for the first time in Earth's history, it will rain. Not for a day, not for a season, but for longer than anything alive today could ever witness. That is where we're headed next, into a rain that will not stop for longer than anything alive today could patiently wait through. The first rain this world has ever known, falling onto a surface finally cool enough to receive it, beginning the long, quiet work of turning a dry, restless planet into one that remembers in every drop that has ever fallen since exactly how it got here. For a long time, nothing happens. The vapor gathers, and gathers further still, thickening into clouds unlike any that will ever exist again on this planet once its history settles into calmer patterns. But still, for a while, the heat rising from below refuses to let any of it fall. Every time a droplet tries to form, tries to gather itself out of the vapor the way water always wants to gather when it's given the chance, the ground beneath it answers back with too much warmth, and the droplet simply returns to vapor before it can ever complete its fall. This standoff between rising heat and thickening cloud continues for what would be, by any ordinary reckoning, an extraordinary length of time. Millions of years pass with the sky holding more moisture than it can release, and the ground slowly cooling, losing its stored heat outward into a space grown a little less violent, a little less crowded with incoming debris than it had been in the planet's earliest and most chaotic age. And then, somewhere on some patch of ground that has finally cooled enough for one particular fraction of one particular moment, the balance tips. A single drop completes its fall. It would be impossible to say exactly when this happened, or exactly where, and it would be a mistake to imagine it as any kind of dramatic turning point, marked by anything at all in the sky or on the ground to suggest that something significant was underway. There was no witness. There was no sound worth listening for beyond whatever a single small drop makes when it finally strikes stone that has waited, in a sense, its entire existence for exactly this. But it happened, somewhere, in some quiet, unremarkable corner of a planet still mostly hostile to anything so delicate. And once it happened once, it began happening again, and again. And soon, in more places than could ever be counted, cooling ground everywhere finally allowed the sky to release what it had been carrying for so long. Picture standing somewhere on this early Earth, in the first true stretch of this new rain, on ground that has only just recently cooled enough to survive contact with falling water without instantly boiling it away. The sky above is not the sky, you know. It holds no blue at all, no gentle grey drifting overhead the way rain clouds drift through a familiar afternoon. It is heavy and low and coloured in shades that shift between a deep, bruised yellow and an ash-darkened black, lit faintly here and there by a sun that manages only a weak, diffuse glow through all that thickness above. And out of that strange, colourless sky, water is falling. Steadily, endlessly, in a way that has no beginning you could point to, and for a very long time yet, no ending in sight either. The ground receives it in a way that feels almost startled, if ground could be startled by anything at all. Steam rises everywhere the first drops land, hissing faintly against stone, still carrying warmth from deep within, a thin white mist curling up from every exposed surface the moment water finds it, evaporating almost as quickly as it falls in these earliest, hottest stretches of the rain. For a long while, this is the pattern. Water falls, ground steams it back into vapor almost immediately. The rain seems, in these early days, to be accomplishing very little beyond a constant, hissing exchange between sky and stone, the same water perhaps falling and rising and falling again in an endless, frustrated cycle before it ever manages to properly rest anywhere at all. But the ground is still cooling, everywhere, all the time, even as this exchange continues. And little by little, patch by patch, certain low places begin holding on to their moisture for slightly longer than they did before. A shallow depression in cooling rock, once merely steamed dry within moments of any rain reaching it, now manages to hold a thin, dark sheen of water for an hour before the last of it finally evaporates away. Then for half a day. Then for a full day. Then, eventually, without ever fully evaporating away at all, before the next fall of rain arrives to add to whatever small amount had managed to survive. This is how the first true puddles came to exist. Not as any single dramatic event, but as a slow accumulation, a place on the surface finally cool enough to let water rest there for longer than it takes to simply steam away again. The sound of this early rain deserves its own particular attention, because it would have been unlike any rain that falls anywhere on Earth today. Ordinary rain, the kind you might be listening to right now if it happens to be raining wherever you are, falls onto soil, onto leaves, onto rooftops, each surface answering back with its own particular texture of sound, softened and layered by everything the water happens to touch on its way down and its way to rest. This early rain fell onto almost nothing but bare, hard, recently molten stone. No soil yet existed to soften anything. No plant of any kind stood anywhere to catch a single drop before it reached the ground. The sound, wherever this rain fell most heavily, would have been sharp and hard and strangely uniform, an endless percussion of water against unyielding rock, occasionally softened only by the low, constant hiss of steam rising wherever the ground still held enough warmth to answer the rain that way. Above all of this, thunder would have rolled almost without pause. A sky this thick, this violently mixed with different temperatures and pressures churning against one another as heat continued rising from below, even while cooler air pressed down from above, would have generated lightning on a scale that has no real equivalent in the calmer skies of later ages. Long, continuous rumbles, overlapping so completely in places that they might have blended into something closer to a single, unbroken roar rather than the separate, distinct claps of thunder you might be more familiar with. Each flash of lightning briefly illuminating a sky too thick and too dark to ever show more than a faint, momentary silhouette of whatever clouds happened to be closest overhead. This rain did not fall in the way rain falls today, arriving in bands and systems that move across a landscape, drenching one region while leaving another dry beneath a temporarily clearing sky. Every account we can reasonably reconstruct of this early period suggests something closer to a near-global, near-continuous event, rain falling somewhere across nearly the entire surface of the planet at almost every moment, for a stretch of time that some estimates place in the range of many thousands of years, and others suggest may have continued, with only brief and partial pauses for stretches, reaching into the millions. It is difficult, and maybe pointless, to try to imagine this in terms of ordinary time. Thousands of years of rain does not mean the same particular raindrop falling continuously without pause the entire time, the way a tap left running might continue for an afternoon. It means something closer to a planet-wide condition, a state the Earth existed in for that entire span, rain occurring almost everywhere, almost always, with dry stretches here and there perhaps, but never a true, complete, planet-wide clearing of the kind you might expect after a single storm passes and the sky settles back into something calm and blue. Picture, if you can hold this image gently rather than trying to grasp it all at once, an entire world beneath cloud, Every volcanic field we described earlier, still smoking in places, still glowing faintly at certain active vents, now also drenched, over and over, by rain falling directly into the same fresh, dark rock those volcanoes had only just finished producing. Every crater left behind by the long bombardment of comets and asteroids, its raw, broken edges softened now by water pooling into every low point the impact had carved, some craters slowly filling completely, holding still, dark water where once there had only been shattered stone and drifting dust. There is a particular kind of geology only this rain could have produced, one that no later age of the Earth would ever quite repeat. Falling water, striking rock still laced with fine volcanic ash, would have carried that ash downward with it into every gathering pool and puddle, staining the earliest standing water a deep, unsettled grey long before it ever had the chance to clear. In some places, where the rain fell heavily against slopes of loose, freshly fractured stone, it would have set entire hillsides sliding, thin rivers of mud and broken rock pouring downhill in slow, heavy sheets, reshaping the ground in a single afternoon in ways that might otherwise have taken far longer to achieve through ordinary weathering alone. This is a planet, in this particular age, defined almost entirely by two things happening at once, everywhere, endlessly. Rain falling. Ground slowly cooling enough to finally let some small portion of that rain remain. There is something worth sitting with in the sheer, patient scale of this. No single day of this rain accomplished very much on its own. A single day's fall, added to ground still largely too warm to hold it, might have produced nothing more lasting than a slightly thicker curl of steam rising briefly before drifting apart into the heavy sky above. But days like this did not happen once. They repeated, essentially unbroken, for a length of time that makes even the patient processes we explored on this channel before, the slow growth of a single stalactite, the gradual carving of a fjord by ice, seem almost swift by comparison. This is patience operating on a scale that most of what we consider ancient or slow simply cannot match. And slowly, through this endless, hammering repetition, water began finding its way not just into shallow depressions and half-filled craters, but into the true low points of the entire planet's surface, the great basins and depressions where the newly forming crust simply sat lower than everything around it, vast regions where, if you trace the shape of the ground carefully enough, water arriving from every direction would naturally be drawn, the way anything follows gravity toward whatever point offers it the least resistance. This is where the first oceans began, not as a sudden filling of some perfectly formed basin all at once, but as the same slow accumulation we've already described, repeated now at a scale vast enough to eventually reshape the entire character of the planet. Picture one of these great low regions in the earliest stage of its transformation. What had been not so terribly long before in the planet's own reckoning, simply a wide, cooling depression in bare volcanic rock, now holds a thin, dark sheet of standing water, deeper in places where the ground dips lowest, barely covering the stone at all along its shallower edges. Rain continues falling into this same basin, day after unbroken day, adding steadily to what has already gathered there, while at the same time, the ground beneath continues its own slow work of losing heat, allowing water to remain a little longer with each passing stretch of time rather than steaming immediately back into the sky. Rivers, in some very early and rough sense of the word, would have begun forming during this same period. Water finding paths of least resistance down whatever slopes separated higher ground from these gathering basins, carving thin, temporary channels into ground still soft enough, in places, to be reshaped fairly easily by moving water. These weren't rivers in any sense that would survive for very long individually. A single channel might exist for a matter of years or decades before some new volcanic flow or some fresh impact reshaped the ground around it entirely, forcing the water to find an entirely new path toward the same low basin it had always been heading toward, regardless of which particular route it happened to take on any given attempt. Some of these earliest channels would have run for only a short distance before simply vanishing into a crack in the rock, disappearing underground the same way we've described water disappearing into limestone in other, much later ages of this planet's story, following the path of least resistance downward rather than onward across the surface. Others found their way blocked entirely by a fresh flow of cooling lava, forced to pool uselessly at the base of an obstacle that had not existed the day before, waiting there until enough pressure built up behind it to either overflow the new barrier or carve a fresh path around it entirely. But regardless of the exact path any single stretch of water took to get there, the destination, again and again, was the same. Down, toward the lowest ground, toward the gathering basins that would, given enough time, become something the planet had never held before: an ocean. It's worth pausing to consider just how strange and how significant this moment actually was in the full context of everything the planet had been through up to this point. For the entire span of time we've traced so far, from the earliest gathering of dust and debris into a molten world, through the long violence of impact and eruption, through the slow release of water from deep within the rock and the equally slow arrival of water carried in from the far edges of the solar system, the Earth had been, in every meaningful sense, a dry world. Not dry the way a desert is dry, holding perhaps a distant memory of water that once was and might return. Dry in the much more absolute sense of a place where liquid water, in any quantity worth mentioning, simply could not exist yet, boiled away the instant it tried to form, evaporated back into an atmosphere too hot and too violent to let it rest anywhere at all. And now, in these gathering basins, for the first time in the planet's entire history, water was beginning to stay. This early ocean, in its first true stretches of existence, would have looked and behaved in ways almost unrecognizable compared to the ocean you might be picturing right now if you happen to live anywhere near a coastline. It was not blue. The sky above it still held too much ash and sulfur and volcanic haze to ever let through the particular quality of light that gives an ocean its familiar color. It was almost certainly a darker, murkier body of water, stained by dissolved minerals and suspended ash falling constantly from the thick sky above, its surface disturbed almost without pause by rain still falling into it directly, by the occasional distant tremor of continuing volcanic activity somewhere along its edges, by the rare, still occurring impact of some remaining piece of the solar system's leftover debris striking somewhere nearby. And this early water was not yet salty. At least not in the way the ocean is salty today. That particular quality, the one we now consider almost inseparable from the very idea of the sea, took its own long stretch of time to develop, and it developed through a process worth pausing over carefully, because it reveals something important about how deeply connected this new ocean already was to the rock and the rain and the volcanic fire that had all played their part in bringing it into existence in the first place. As rain continued falling, not only into the gathering basins themselves, but across the wider landscape surrounding them, that water did something water has done ever since it first existed anywhere in any form. It moved across the surface, and as it moved, it interacted with whatever rock it happened to touch, dissolving small amounts of mineral out of the stone the same slow, patient way we explored in an earlier journey on this channel, water dissolving limestone to carve out entire cave systems given enough time. This early rock, freshly formed from cooling volcanic material, released its own particular blend of dissolved minerals into every stream and rivulet of water that crossed it, minerals rich in elements like sodium and chlorine among many others, the very same elements that, combined, produce ordinary salt. Every stream carrying this mineral-laden water eventually made its way, as all water on this planet eventually did, down toward the same great gathering basins that were slowly becoming ocean. And once that mineral-rich water arrived, it did not simply leave again, water evaporating back up into the sky. Continuing the endless cycle we'll explore more fully very shortly, carried only pure water vapor back upward, leaving whatever dissolved minerals it had been carrying behind. Dissolved now, not in a small stream anywhere on the surface, but in the steadily growing body of the ocean itself. This is how the sea became salty. Not through any single dramatic event, but through the same kind of patient accumulation that built literally everything else in this story so far. Rain fell. Rain touched rock and dissolved a small trace of mineral from it. That mineral-laden water made its way down into the gathering ocean. The water alone evaporated back upward, leaving its dissolved cargo behind. And this cycle repeated, essentially without pause, across a length of time so vast that even a process this slow and this seemingly minor eventually produced an ocean holding within it enough dissolved mineral to give seawater the particular taste and character it has held ever since. A taste that, if you have ever swum in any ocean anywhere on this planet, connects you in a very real and very literal sense back to mineral first dissolved out of some of the very earliest rock this world ever produced. There is a quiet irony worth noticing in this slow accumulation of salt, one that only becomes clear once you consider it from the ocean's own perspective, if an ocean could be said to have one. The rivers feeding it were never salty themselves. Then or now, water running down from rain and melting ice, generally carrying only a faint trace of dissolved mineral by the time it reaches any river's mouth. It is only the ocean itself, receiving that faint trace again and again from countless separate streams across an almost incomprehensible span of time, and then losing pure water back to the sky through evaporation while keeping every trace of mineral behind that ever became salty at all. The rivers gave a little. The sky took a little back, but only ever the water itself, never what the water had carried. And so the ocean, alone among all the water on this planet, became the one place where that mineral was allowed to simply keep gathering, one small addition at a time, for as long as this whole cycle has continued. Picture, now, standing at the edge of one of these earliest true oceans, at some point deep enough into this process that the water has begun, in a real sense, to feel like an ocean rather than simply an enormous gathering puddle. The rain, though it has not stopped completely, has begun easing in places, allowing brief stretches where the surface of this early sea sits calm enough to actually reflect something of the strange, heavy sky hanging above it. The water still carries a darker, more mineral-stained quality than any ocean you have ever personally seen. Yet it is unmistakably an ocean now, stretching beyond the horizon in every direction beneath the heavy sky. Gentle swells rise and fall across its surface, responding for the first time to a force that has been waiting overhead since the moon itself was born. Those first tides were faint, almost tentative, but they marked the beginning of a rhythm that has never stopped. The newly formed moon, born from the same ancient collision that reshaped the young Earth, was already tugging gently at the growing ocean from its orbit overhead. Slowly, the water answered. It rose and fell in the earliest version of the tides that still touch every shoreline on Earth today, beginning a partnership between the moon and the oceans that has lasted for more than 4 billion years. And gathered within that water, though it will still be an unimaginably long stretch of time before anything alive exists anywhere to appreciate it, is the same basic material, the same hydrogen and oxygen bound together in the same simple, patient molecule that first arrived here billions of years ago, released from deep within the planet's own restless interior, or carried across an unthinkable distance from the cold, dark edges of the solar system, riding along on some ancient fragment of comet or asteroid that had spent its entire prior existence adrift, waiting, in a sense it could never have known, for exactly this moment, for exactly this arrival, for exactly this rest, finally settling after everything it took to get here into the first great ocean this world had ever known. We'll leave that early sea resting quietly here for now, its dark surface holding whatever faint, filtered light manages to reach it through the still thick sky above, and we'll turn next toward what happens once that water, having finally arrived and finally settled, begins doing something it has done every single day since, rising back up into the sky, gathering into cloud, and falling again, beginning a cycle that has never once stopped turning from that first early ocean all the way to this very night. Somewhere in that early ocean, at its surface, a single molecule of water is doing something it has never done before. It is leaving, not all at once, and not with any particular urgency. It simply happens to be sitting close enough to the surface and warm enough that the bond holding it loosely among its neighbours finally gives way, and it slips upward out of the liquid it had belonged to only a moment before and into the air above, invisible now, scattered among countless other molecules undergoing exactly the same quiet transformation at every square inch of this vast, dark ocean's surface, all at once, all the time, without any of them needing permission or announcement to do it. This is evaporation, and it had been happening, in some form, ever since the very first puddle managed to survive for more than a few moments without steaming completely away. But now, with an ocean this size finally gathered and settled, evaporation was happening on a scale the planet had never produced before, water rising continuously from the entire surface of every sea and basin at once, feeding back into a sky that had, until this point, mostly been losing its moisture downward rather than receiving any of it back. Picture this exchange happening across the whole visible surface of that early ocean at every hour, without pause. Near the equator, where the weak, filtered light of the young sun manages to deliver slightly more warmth than it does elsewhere, evaporation happens fastest, invisible columns of rising vapor thickest here, where the water is warmest and the exchange between sea and sky is most active. Toward the poles, where whatever cold exists on this still young world gathers most persistently, the same exchange continues, but more slowly, more reluctantly, the ocean surface there giving up its moisture at a gentler pace than its warmer counterpart nearer the equator. This rising vapor does not simply drift upward forever, spreading thinner and thinner until it disappears entirely into the emptiness of space. It rises only until it reaches air cold enough to make it uncomfortable, in a sense, for it to remain as vapor any longer. And there, at that particular height, something begins to happen that had, until this point in Earth's history, only ever happened as part of one single, continuous, world-spanning event: condensation. The molecules of water vapor, cooling as they rise, begin gathering together again, clustering around whatever fine particles of ash or dust happen to be drifting at that same height, providing a surface, however small, for water to begin condensing back into. One molecule joins another, then another, and slowly, at that particular altitude, a cloud begins to form, not the vast, planet-wrapping blanket of the earliest ages we described before, but something smaller, more distinct, a single gathering of moisture drifting on its own through a sky that has finally calmed enough to let individual clouds exist as separate, recognizable things rather than one continuous, unbroken cover stretching from horizon to horizon. This is, in its own quiet way, one of the more significant moments in this entire long story, though it would have looked, to anyone able to witness it, like almost nothing at all. a single cloud forming and drifting, doing nothing more dramatic than holding its shape for a while before eventually releasing its moisture back down as rain, somewhere over land or somewhere back over the very ocean it had risen from only days before. And yet this simple act, repeated now continuously, everywhere, marks the true beginning of something that has not stopped operating, not for a single day in all the time since. The water cycle. It's worth taking a moment here to notice exactly what makes this cycle different from everything we described in the earlier stages of this story. The endless rain that first filled the oceans was, in a sense, a one-directional event, water moving from sky to ground and, for the most part, staying there once the ground finally cooled enough to hold it. What begins now, once the ocean has grown large enough and stable enough to sustain continuous evaporation, is something closer to a genuine circuit. Water leaving the ocean as vapor, gathering into cloud, falling again as rain, and eventually finding its way, by one path or another, back to the very ocean it started from, ready to repeat the entire journey once again. Picture a single molecule of water, the same kind of molecule we've been quietly following since it first arrived on this planet, now caught up in this new circuit for the first time. It rises from the ocean's surface as vapor, drifts upward and outward on whatever faint winds move through this early atmosphere, cools as it climbs, and eventually finds itself part of a small, gathering cloud drifting slowly over land that has, by this point in the story, begun to rise clear of the ocean in scattered patches, the first true continents beginning to take shape from the same volcanic material that built everything else in this story so far. That cloud, carried onward by the wind, eventually releases its burden as rain, and our single molecule, along with countless others exactly like it, falls once more, though this time not onto bare, glowing volcanic rock cooling for the very first time, but onto ground that has already been rained on many times before, ground beginning, ever so slightly, to show the earliest signs of the kind of weathering and erosion that will eventually shape every landscape this planet ever produces. From here, our molecule has choices, in the loose sense that water always has choices, following whichever path offers the least resistance at each particular moment. It might land in a place where the ground slopes gently downward, joining with other rainfall to form one of those early, temporary rivers we described before, tracing a path back down toward the ocean across the course of a single journey, rejoining the sea it originally rose from within a matter of days or weeks. Or it might land somewhere flatter, somewhere with no clear downward slope to follow, sinking instead directly into the ground itself, beginning an entirely different kind of journey, one that might not bring it back to any ocean or any sky for a considerably longer stretch of time than a single rainstorm's aftermath. Either way, once it evaporates again, whether from a river's surface, from a puddle warming under whatever sun manages to break through the sky, or eventually from the ocean itself after however long a journey brought it back there, the cycle simply continues. Up, cool, gather, fall, down toward the lowest available point, whichever path that happens to be, and up again, whenever enough warmth returns to loosen it free once more. This is the cycle that has not stopped turning, not for a single day, from that earliest scattered cloud drifting over the first patches of exposed land, all the way to this very night, wherever you happen to be lying as you listen to this. Every raindrop that has ever fallen anywhere on this planet, in every age since this cycle first began, has been part of this same unbroken circuit. Water rising, water falling, water finding its way back, eventually to wherever it started, only to rise again and repeat the entire journey once more. There is something worth sitting with in just how quickly, relative to everything else in this story, this particular cycle established itself as one of the planet's fundamental, unchanging processes, The formation of the Earth itself took hundreds of millions of years. The slow release of water from deep within volcanic rock took a similarly vast stretch of time to accumulate into anything significant. But once the ocean existed, once the sky had cooled enough to allow individual clouds rather than one continuous cover, the water cycle itself began operating almost immediately, in geological terms, settling into essentially the same basic pattern it still follows today, adjusting itself gradually over the following billions of years to changes in climate, in the shape of the continents, in the composition of the atmosphere itself, but never once fundamentally stopping, never once needing to be reinvented from scratch the way so many of the earlier stages of this story required entirely new conditions to even become possible. Picture the sky above this early world settling, gradually, into something that would begin to look at least somewhat familiar if you squinted past all the remaining differences. Individual clouds, distinct from one another, casting individual shadows across the ground below as they drifted on whatever winds carried them. Clear stretches of sky opening up between those clouds, at least occasionally, allowing a weak, filtered version of daylight to reach the surface directly rather than being scattered and diffused through one endless, unbroken layer of ash and cloud above. Rain, when it fell, beginning to fall in genuine, distinct storms rather than one continuous, planet-wide event, a storm passing over one region while another region, not too terribly far away, might sit beneath clear sky at the very same moment. This is, in its own quiet way, the moment weather itself was born. Not simply water falling from the sky, the way it had been for that long, planet-spanning rain we described earlier, but distinct, separate weather systems, moving independently across a planet finally calm enough, finally cool enough, to let such systems exist as their own particular events rather than one continuous, undifferentiated deluge covering everything at once. The particular shape each cloud took during this period depended on the same basic forces that shape clouds today: rising columns of warmer, moisture-laden air pushing upward into cooler layers above, building tall where the air rose quickly and forcefully, spreading flat and low where it rose more gently and gradually. Somewhere over the warmer stretches of that early ocean, a column of especially humid air might rise fast enough and high enough to build one of the first true storms this planet had ever produced as a distinct, contained event rather than simply another undifferentiated portion of the endless earlier deluge, its own separate system of wind and cloud and rain moving across a stretch of open water, before eventually reaching whatever early coastline happened to lie in its path, releasing its accumulated moisture there in a single, concentrated burst rather than the featureless, continuous fall of the earlier age. And as this cycle settled into its now familiar rhythm, it began doing something else, something quieter and less immediately visible than rain or cloud or storm, but every bit as significant to the story we're following tonight. It began sending some of its water downward, not into rivers or lakes or the ocean itself, but directly into the ground, disappearing from view entirely, beginning a journey that would take it somewhere the rain and the cloud and the ocean's own surface could never quite reach. To understand where this particular portion of the water cycle leads, it helps to picture the ground itself not as a single, solid, uniform mass, but as something closer to what we explored in an earlier journey on this channel when we travelled beneath the surface of the modern Earth entirely. Layers of rock, some dense and solid, resistant to water finding any way through them at all, and others more porous, holding countless tiny spaces between individual grains of stone, spaces small enough to be invisible to the eye but numerous enough, collectively, to hold a genuinely significant quantity of water once it finds its way down into them. Picture our same single molecule of water, having fallen once again as rain, this time landing on ground that happens to sit above one of these more porous layers of rock rather than draining away immediately into a river or pooling on the surface until it evaporates back into the sky. It sinks. Slowly, at first, moving through whatever thin layer of loose, weathered material has begun accumulating on the surface by this point in the planet's history, and then deeper into the rock itself, finding its way into the tiny, connected spaces between mineral grains that we call, when enough of them exist together in one place, an aquifer. This is a very different kind of journey than the one our molecule experienced when it simply ran downhill toward a river and back to the ocean within a matter of days. Water entering an aquifer moves at a pace that has almost nothing in common with the speed of a river or the drama of a storm. It creeps forward through gaps between grains of rock barely wider than the water molecules themselves, pushed along not by any strong current but simply by gravity and by the gentle, constant pressure of more water arriving from above, pressing whatever is already there a little further along, the way a very long, very slow line of people might shuffle forward one small step at a time as more people join at the back. Some water entering an aquifer during this early period of Earth's history might remain there, moving only a handful of meters over the course of an entire human lifetime's worth of years, for a length of time reaching into the thousands or even the tens of thousands of years, before it ever finds its way back out again, emerging eventually as a spring somewhere far from where it first sank into the ground, or simply remaining exactly where it settled, part of a vast, slow, underground reservoir that the rest of the planet's surface, rushing along through its rivers and its storms and its endlessly cycling clouds, mostly forgets is even there at all. This underground portion of the water cycle deserves real attention, precisely because it moves at such a different pace from everything else we've described tonight, and because it represents, even from these very earliest stages of the planet's history, a genuine and significant portion of all the water this world holds. Water sitting in an aquifer isn't gone from the cycle. It hasn't left the system entirely. It's simply paused there, resting in the dark, in stone, for a length of time that can stretch far beyond anything the surface portion of the cycle typically produces, before eventually, given enough time and the right conditions, finding its way back to the surface and continuing the same journey it had always been on. Picture this early aquifer forming beneath ground that, on the surface, looks almost entirely unremarkable, a stretch of gently sloping volcanic rock, weathered just enough by this point to hold a thin covering of loose material, rained on regularly by the same storms passing overhead that we described only a moment ago. Beneath that ordinary-looking surface, invisible to anything standing above it, water has been quietly gathering for a very long time, filling every available space between grains of porous stone, forming a body of water that, though it could never be seen directly from above, holds within it a volume that might rival or even exceed many of the small lakes and seas visible on the surface during this same period. The particular kind of rock this early water found its way into mattered a great deal to how it settled and how long it eventually stayed. Where the volcanic material had cooled quickly, trapping small pockets of gas inside itself as it hardened, the resulting rock held countless tiny air pockets, later filled just as readily with water once enough time and enough rainfall allowed it to seep downward and claim that space for itself. Where the same volcanic material had instead cooled slowly, forming a much denser, more solid stone with almost no internal space at all, water found itself blocked entirely, forced instead to travel sideways along the boundary between that dense layer and whatever more porous material happened to sit above or below it, tracing paths determined entirely by the particular arrangement of rock this young planet had happened to produce in that exact location. This water, held in the dark, held in stone, existing in almost total stillness compared to the constant churning motion of rain and river and evaporating ocean surface above it, represents something the rest of the water cycle rarely offers: a genuine pause. A place where our single molecule of water, having spent whatever portion of its existence so far caught up in the endless, rapid cycling of rain and cloud and river, might simply rest, undisturbed, for a length of time long enough that entire mountain ranges elsewhere on the planet might rise and begin eroding away again before it ever moves on to wherever its next destination happens to be. And yet, even resting this deeply, this quietly, our molecule has not actually left the cycle at all. It is still, in every meaningful sense, part of the same water that first evaporated from that early ocean, that first fell as rain onto ground still cooling from its violent formation, that first arrived on this planet, whether from deep within its own molten interior or carried across an unthinkable distance from the cold, distant edges of the solar system. It has simply found, for the moment, one of the cycle's quieter corners, one of the places where water can wait, patiently, without any pressure to keep moving, until whatever combination of pressure and gravity and time eventually nudges it back toward the surface, toward a spring, toward a river, toward the ocean it will eventually, however many thousands of years from now, find its way back to once again. There is a particular kind of relationship worth noticing between this deep, slow-moving underground water and the fast, restless cycle happening above it at every moment. The surface world knows almost nothing of what's held beneath it, rain falling and evaporating and falling again in a rhythm measured in days and weeks, entirely indifferent to the vast, patient reservoir sitting quietly just beneath its own feet, moving on a timescale that the surface cycle could never hope to match or even properly comprehend. And yet the two are never truly separate. Every drop resting in that early aquifer arrived there by falling, at some point, as ordinary rain, and every drop will eventually leave it by rejoining that same restless surface cycle, however long the wait between arrival and departure happens to be. The underground world and the world above it are not two different systems at all, simply two very different tempos within the very same one. There is something worth carrying forward from this particular stage of the story. Something that connects directly to nearly everything else we've explored on this channel before. Every aquifer that exists today, everywhere on the planet, holding water that fell as rain, sometimes centuries or millennia before anyone alive today was born, traces its basic principle back to this same early period, back to the very first stretches of ground porous enough and stable enough to hold water resting quietly in the dark rather than rushing immediately back toward the surface cycle above. The underground world we explored in such detail in an earlier journey, the slow, patient reservoirs holding water far older than any river's flow, did not appear suddenly at some later point in Earth's history. It began here, in these earliest stretches of the water cycle's operation, as soon as there was both water to spare and rock porous enough to hold it, resting quietly beneath a surface that, at the time, was still mostly bare volcanic stone, still only beginning to show the first faint traces of whatever richer, more complex world it would eventually become. We'll leave this early aquifer resting now, wherever beneath the surface of this young planet it happens to be gathered, holding its water in stillness and darkness while, above it, the ocean continues evaporating, the clouds continue gathering and releasing their rain, and the whole restless cycle we've just described continues turning, exactly as it always has, exactly as it will continue turning, for the entire remainder of this planet's long history, carrying our same water, our same patient molecule, onward toward whatever destination the next stage of this journey happens to hold. Not every drop of water that fell from those early clouds found its way into an aquifer or a river or straight back to the ocean it started from. Some of it took a different path entirely, one that led not downward into stone, but upward, toward the coldest reaches of the planet, where the cycle we've been following slows almost to a stop, and water stops moving as liquid altogether. To understand this part of the story, it helps to leave the warm, restless ocean for a while, and travel instead toward the poles of this still young Earth, and toward the highest points of whatever early land masses have begun rising above the surface by this stage. Even in a world only just beginning to settle into something like a stable climate, temperature was never distributed evenly across the whole surface. Near the equator, where the weak early sun still delivered its greatest share of warmth, the ocean stayed liquid without difficulty, evaporating steadily, feeding the clouds we've already followed. But further from that warmth, in the regions nearer the poles and at elevation, where thinner air held less heat than the thick lowland atmosphere below it, conditions were different. Colder, quieter. A place where rain, falling from the same clouds that watered the rest of the planet, sometimes never reached the ground as rain at all. It arrived instead as something else. Picture a cloud drifting inland from that early ocean, carried by whatever winds moved through this world's still forming atmosphere, climbing gradually as it crosses higher ground. As it rises, the air around it cools, the way air always cools with altitude, and the moisture it carries begins to condense, not into the ordinary raindrops that fall over warmer country below, but into something colder, more delicate, more resistant to gravity's pull. Small crystals of ice, each one forming around some tiny particle of dust or ash drifting at that height, growing outward in whatever intricate geometry the cold and the moisture happen to produce, and then, once heavy enough, releasing from the cloud and beginning their own slow fall toward the ground far below. Snow. It settles quietly over ground that has likely never held it before, over stone still bearing the scars of volcanic eruption and impact from ages we've already left behind in this story, over slopes rising toward whatever modest heights this young planet's land masses have managed to build so far. And unlike the rain falling in warmer country nearby, this snow does not simply vanish back into the ground the way liquid water does. It rests there, white against the dark volcanic stone beneath it, at least for a while, until the sun, weak as it is at these latitudes and elevations, finds enough strength to melt it away again. In most places, that melting happens quickly enough. A single snowfall, briefly covering the ground, gone again within days as the temperature climbs even slightly. But in certain places, at certain elevations, in certain regions close enough to the poles that warmth never quite gathers the strength it needs, the snow that falls does not fully melt before the next snowfall arrives to cover it again. And this is where something new begins. Picture one particular slope, high above whatever coastline lies far below it, cold enough throughout the year that summer's brief warmth never manages to clear away everything winter deposited. Snow falls here, season after season, each new layer settling over whatever remained from the layer before, never quite disappearing entirely before the next arrival buries it further. In the earliest years of this accumulation, it is simply snow, deep and white, and largely unremarkable, the kind of scene that could exist almost anywhere cold enough on the planet's surface. But snow, unlike rain, carries a great deal of trapped air within its structure, each individual flake a loose, delicate lattice, holding far more empty space than solid substance. And as more snow falls on top of what came before, the weight of everything above begins pressing down on everything below, squeezing that trapped air outward, packing the loose crystals closer together, transforming what was once light and airy into something considerably denser. Given enough seasons of this slow compression, the snow at the bottom of the accumulating pile stops being snow at all in any ordinary sense. It becomes something granular, something with real weight and real resistance, something that would push back firmly against a hand pressed into it rather than simply giving way. This intermediate stage, sitting somewhere between loose snow and true ice, holds its shape in a way fresh snowfall never could. And beneath that layer, compressed further still by everything accumulating above it, something else begins to happen. The remaining trapped air, squeezed out almost entirely now, leaves behind a material that is no longer granular at all, but dense and clear in places, and holding within its structure almost none of the emptiness that once defined the loose snow it originated from. Ice. Not the thin, brittle ice that might form overnight on the surface of a still pond, but something built up over many seasons of accumulation and pressure, dense enough and old enough to hold its shape indefinitely, resting on that same cold slope where the first snowfall of this whole sequence originally settled. This is how the first true ice of this planet's history came to exist. Not as water freezing suddenly on some cold night, the way ice had certainly formed in smaller, more temporary ways many times already by this point in the story, but as something built gradually, season after season, out of snow that never fully left before more snow arrived to join it. A structure built the same patient way everything else in this story has been built, one small addition at a time, until the accumulated weight of all those additions produced something genuinely new. And once ice like this exists in sufficient quantity, gathered thick enough on a slope steep enough, it stops behaving like something simply resting in place, and begins, instead, to move. This might seem strange to picture, ice moving the way water moves, but the physics involved, though considerably slower, isn't so different in principle. Deep within a sufficiently thick body of ice, the weight of everything above presses down with enough force that the ice at depth, though still solid, begins to deform very gradually under that pressure, flowing outward and downward the way honey might flow if given enough time and enough of its own weight pressing it forward. Not liquid, not anything you would recognize as flowing in the ordinary sense, but moving all the same, carrying the ice above it slowly downhill, following whatever slope the underlying ground happens to offer. This is a glacier, and this early Earth, once its climate had settled enough to allow snow to accumulate faster than warmth could clear it away in certain high, cold regions, produced glaciers of its own for what may well have been the first time in the planet's history. Picture one of these early glaciers from somewhere at a comfortable distance, high on the flank of whatever modest peak or ridge it has claimed as its home. Its surface, where exposed to open air, holds a texture unlike anything else on this planet at this stage of its story, ridged and folded by the slow internal movement happening beneath, catching whatever light filters down through this world's still hazy atmosphere and returning it in a pale, cold glow that stands out sharply against the dark volcanic stone surrounding it on every side. Where the ice has grown thick enough to reveal its deeper layers, at the edge of a crack or a crevasse opened by the glacier's own slow movement, a colour becomes visible that would have been entirely new to this planet at the time. A deep, saturated blue, found nowhere else in this early world's palette of black volcanic rock and grey ash, and the pale, filtered daylight struggling through a still settling sky. This blue exists only because the ice has grown old enough and compressed enough to have squeezed out nearly all the trapped air that once scattered light in every direction through the looser snow above. What remains lets light travel further into the ice before returning it to the eye, and in doing so, produces a colour the surface world above it has never held before. This glacier moves at a pace that makes even the slow underground water we described a little while ago seem hurried by comparison. A few centimetres in a day, if that. Enough that no observer standing beside it for even a full season would notice any visible change in its position. And yet, given the vast stretch of time this entire story has already asked us to hold in mind, that pace adds up to something considerable. Given enough centuries, this glacier will have crept a genuine distance down its slope, grinding whatever loose rock and debris happened to lie in its path, carrying that material along within its own frozen body, depositing it eventually wherever the ice finally grows thin enough to release what it has been carrying. The water held within a glacier like this one occupies a strange position within the larger cycle we've been following. It has not left the cistern, any more than the water resting quietly in that early aquifer had left it. But it has entered one of the cycle's slowest possible states, locked into a form that can hold itself in place for a length of time far beyond anything the ocean's own surface, or even the underground reservoirs we explored a little while ago, typically produce. Some of the water held in these earliest glaciers may have remained frozen for thousands of years without ever once returning to liquid form, resting through entire cycles of climate shifting warmer and then colder again, entire ages during which the rest of the planet's water continued its restless circuit of evaporation and rainfall and river and return, indifferent to this one particular portion of itself, sitting motionless, held fast, high above the ocean it once rose from as vapor. And this early ice held something else within it too, something that would prove valuable to anyone much later in this planet's story, curious enough to study it closely. Trapped within the structure of glacial ice, sealed away as each new layer of snow buried the layer before it, tiny pockets of the atmosphere from the exact moment that snow fell remain preserved, undisturbed, for as long as the ice itself survives. A single bubble, no larger than a grain of sand, holding within it a sample of air breathed by no living thing, but present all the same, from a sky that existed only briefly, once, at one particular moment in this planet's long and still unfolding history. This early Earth did not yet know it was creating something that would one day allow a much later form of curious, patient creature to read its own atmosphere's history directly, layer by layer, the way you might read the pages of a book written entirely in ice. But the principle was already in place from these earliest glaciers onward, every layer holding its own small, sealed record. Every glacier, in its own quiet way, keeping notes on a world it had no means of understanding, simply by doing what ice has always done, gathering and compressing, and holding whatever happened to be present at the moment it formed. Across the wider planet, this early period of glacial formation was neither constant nor complete. Ice gathered where conditions allowed it, and receded where they didn't, growing during colder stretches of this world's still settling climate, shrinking again when warmth returned. This early Earth, in other words, had already begun the same long rhythm of advance and retreat that would repeat itself in far more dramatic form many times across the planet's later history. Entire ages when ice would spread across enormous stretches of the surface before withdrawing again as the climate shifted back toward warmth. We won't follow every one of those later, larger ice ages in detail tonight. What matters for the story we're telling is simply this: that ice, once it existed at all on this planet, became a permanent feature of the water cycle from that point onward, a slow, patient reservoir sitting alongside the equally slow reservoir of underground water we explored a little earlier, both of them holding a portion of the planet's total water in states far removed from the restless liquid churning through rivers and clouds and ocean waves above and around them. And within that ice, resting in whatever glacier happened to hold it at any given moment, our own patient molecule of water, the one we've followed since it first arrived on this planet however many ages ago, might easily have found itself, at some point in this unfolding story, caught up in exactly this kind of pause, rising as vapor from the ocean, cooling, gathering into cloud, drifting inland on some ancient wind, falling, this time, not as rain but as snow, over ground cold enough to keep it, settling, compressing, becoming, over the slow accumulation of many such falls, part of something that would not move again, in any meaningful sense, for centuries or millennia, held in stillness on a mountainside, while the rest of the world it once belonged to continued its restless, endless circuit far below. There is something worth sitting with in the particular quality of a world that holds both extremes within its water cycle at once. An ocean, warm and restless, evaporating constantly, feeding clouds that release their burden as rain within days of gathering it. And, not so very far away in the same planet's geography, ice sitting motionless for ages at a stretch, holding its water in a form so still it might as well have left the cycle entirely, if not for the certainty that, given enough time, it always eventually returns. This is, in its own way, the first true expression of patience this planet's water had shown. The rain that filled the original ocean fell without pause for what may have been thousands of years, but it was still, in its essential nature, water in motion, falling, gathering, filling basins as quickly as those basins could be filled. The ice forming now, on cold slopes far from the ocean's warmth, represents something different. Water choosing. In the only sense water can be said to choose anything, simply to rest, to hold still, to wait, without any particular urgency, for whatever combination of season and warmth and time might eventually free it to move again. And all the while, this same planet, having built its ocean, established its cycle of evaporation and rainfall, opened its first patient reservoirs of water underground and its first patient bodies of ice at elevation, was undergoing another transformation entirely, one that would eventually give this whole unfolding story a kind of significance it had never possessed before. Somewhere in that early ocean, in the shallow, sunlit water near its edges, something had begun to stir that was not simply water, or rock, or vapor, or ice. Something had begun, very quietly, to live. It would be easy to imagine that life, once it appeared, was something entirely separate from everything we've followed so far in this story. A new arrival, distinct from the water and rock and air that had occupied this planet for so long before it. But the truth sits closer to the opposite. Whatever first stirred in that ancient shallow water did not arrive from somewhere else, the way some of Earth's original water arrived from comets and asteroids drifting in from the outer reaches of the solar system. It emerged directly from the very water and chemistry already present, assembled itself, slowly and without any plan or intention behind it, out of the same basic materials that had been cycling through this planet's oceans and atmosphere for ages already. And whatever this first living thing was, however simple, however far removed from anything you would recognize as alive if you saw it under a microscope today, it needed water to exist at all. Not as an occasional convenience, the way you or I might reach for a glass of water when thirsty, but as an absolute, foundational requirement woven into the very structure of whatever chemistry allowed it to hold itself together, to maintain whatever fragile boundary separated its inside from the ocean surrounding it, to carry out whatever first faint processes of growth and reproduction eventually, defined it as something different from the lifeless water around it. Every living thing that has ever existed on this planet, from that first uncertain stirring in the shallow water of an early sea, all the way to you, listening to this story now, wherever and whenever you happen to be, shares this same absolute dependence. Water is not simply something life uses. It is, in a very real sense, the medium life first learnt to exist within, the substance every early chemical process needed close at hand in order to function at all, the same way fire needs air or a wave needs water to carry it. Take the water away, even briefly, and whatever fragile chemistry had assembled itself into something we might call living collapses back into ordinary, lifeless matter, indistinguishable from the rock and minerals surrounding it. Picture that first shallow water again, warmer than the deep ocean beyond it, closer to the surface where whatever weak sunlight this early atmosphere allowed through could actually reach. Within it, dissolved minerals drift freely, carried down from the same volcanic rock and eroding early land masses we've already followed through earlier stages of this story, mixing constantly with the water itself in a slow, ongoing exchange that had been happening for ages before anything living existed to make use of it. Somewhere within that mixture, purely as a matter of chemistry rather than any kind of intention, certain molecules began interacting in ways that allowed them to persist a little longer than they might have otherwise, to hold together a little more consistently, to occasionally produce rough copies of themselves out of the same raw materials constantly drifting past in the surrounding water. None of this happened quickly. None of it happened with any clear boundary marking the moment when ordinary chemistry became something we might call life. It emerged the way nearly everything in this story has emerged, gradually, out of countless small interactions repeating themselves over a stretch of time too long to properly hold in mind, until what had once been simple chemical reactions slowly became something capable of maintaining and reproducing itself. And every one of these earliest processes, whatever they were, however far removed from anything resembling a modern cell, depended entirely on the surrounding water to function. Water dissolved the minerals these earliest chemical systems needed. Water carried those minerals close enough to interact with whatever fragile structures were assembling themselves. Water provided the medium within which those structures could hold their shape without immediately drying out and losing whatever fragile coherence they had managed to establish. Without the ocean surrounding it, whatever first stirred to life in that shallow water would have had nowhere to exist at all. As life slowly grew more complex across the ages that followed, this fundamental relationship with water never loosened. If anything, it deepened, becoming more intricate, more essential, more thoroughly woven into the basic structure of whatever new forms of life eventually emerged from that same ancient ocean. Consider, for a moment, what water actually does within a living body, any living body, from the simplest single-celled organism drifting in that early sea to the most complex creature walking, swimming, or flying across the planet today. It provides the medium within which every chemical reaction a body depends upon can actually take place, dissolving and carrying the countless different molecules a cell needs to function, allowing them to meet and interact in ways that would be impossible if everything remained dry and separate. It regulates temperature, absorbing and releasing heat far more effectively than almost any other common substance, allowing a body to withstand fluctuations in its surrounding environment that would otherwise threaten to overwhelm it. It provides structure, filling cells and tissues with enough pressure to hold their shape, the same way water filling a balloon gives that balloon its form. And it serves as the medium of transport throughout a body, carrying nutrients to where they're needed and carrying waste away from where it would otherwise accumulate and cause harm. None of this changed in its essential nature as life grew more complex. A single-celled organism drifting in that early ocean, and a much later, far more elaborate creature built of countless trillions of individual cells both depend on water for exactly the same basic reasons. Water as medium, water as regulator, water as the substance that allows the whole intricate machinery of life to function at all. The scale changed enormously. The underlying necessity never did. This is worth pausing on because it reframes something you might otherwise take entirely for granted. The water in your own body right now, the fluid filling your cells, carrying oxygen through your blood, regulating your temperature as you lie there listening to this, is not simply present because your body happens to need it. It represents a relationship between water and life that stretches back, unbroken, to that very first stirring in the shallow water of an early sea. A relationship that has never once been interrupted across the entire span of life's existence on this planet. Every creature that has ever lived, every plant that has ever grown, every organism of any kind that has ever existed anywhere on Earth's surface has depended on this same basic substance in essentially the same basic ways, drawing it in, using it, releasing it back into the wider cycle we've been following throughout this whole story, only to draw in more again as needed, in a rhythm that has never once fully paused since it first began. And it's worth remembering too, that the water any given living thing depends on was never created specifically for that purpose. It is the exact same water that first rose from the Earth's own molten interior as vapor, or arrived across the emptiness of space carried by comets and asteroids from the solar system's cold outer reaches. The exact same water that filled the earliest oceans, evaporated into the first true clouds, fell as the first true rain, sank into the first true aquifers, gathered into the first true glaciers. Life did not receive its own separate supply of water, set apart somehow from everything the planet had already produced. It simply learned, slowly and without any plan behind it, how to make use of water that had already been cycling through this world for ages before anything living existed to need it at all. Picture, once more, our single patient molecule of water, the one we've followed loosely across this entire unfolding story, from its arrival on this planet, however many ages ago, through fire or through ice, through the endless rain that first filled the oceans, through evaporation and cloud and the settling rhythm of the water cycle, through a long rest in an aquifer or a longer rest still within the slow-moving body of a glacier. Somewhere in this story, whether early or late, that same molecule might easily have found its way into the shallow water where life first stirred, might have been drawn in by whatever early living process needed it, held briefly within some ancient, simple form of life before eventually being released again, back into the ocean, to continue whatever journey remained ahead of it. This is not a small thing to sit with, quietly, at the edge of sleep. The water that first made life possible on this planet, however many hundreds of millions of years ago that quiet stirring in the shallows actually happened, is the very same water still cycling through the world today, the very same water pooling in oceans, gathering in clouds, resting in aquifers and glaciers, and moving, right now, through every living body on the surface of this planet, including your own. You are not separate from this story any more than the mountains were separate from the story that built them. The water inside you tonight has been ocean, it has been cloud, it has been ice, resting somewhere high and cold and still for however long that particular pause happened to last. It has been part of countless other living things before it ever found its way into you. Part of a journey that began when a young, dry, glowing planet first, however slowly, however reluctantly, breathed its water into a sky finally cool enough to hold it. That water is still moving tonight, in you and around you, and it will keep moving long after this particular part of its journey has ended, released eventually back into the same vast, patient cycle it has belonged to since the very beginning. That single molecule, resting now somewhere inside you, is not the end of this story. It's simply the point where the story has, for the moment, arrived close enough to notice. Look around the room you're lying in, if your eyes are still open even slightly, or simply picture it if they've already closed. Somewhere near you, water is present in forms so ordinary you'd never think to call them remarkable. A glass on the table beside the bed, its surface catching whatever thin light still reaches it. The faint dampness in the air itself, present even in a room that feels, by any ordinary measure, completely dry. The moisture held quietly within the walls, within the wood of the furniture, within the fabric wrapped around you right now, holding on to trace amounts of the very same substance we've spent this whole story following. None of this water arrived recently. None of it was made specifically for this room, or this night, or you. It has been part of this planet since long before there was a planet recognizable as this one, cycling continuously through every form we've described. Ocean and cloud, ice and rain, aquifer and living body, without ever once running out, without ever once needing to be replenished from anywhere beyond the world it already belongs to. There is a particular way of understanding this that changes how the whole planet feels once you sit with it for a while. Earth does not receive a new supply of water each year, the way a reservoir might be topped up by a passing storm. The amount of water on this planet, in every form it takes, has remained essentially the same for an almost incomprehensible stretch of time, moving constantly between one state and another, but never truly leaving the system it has belonged to since those first oceans gathered and settled. The water evaporating from the sea outside some coastline tonight is not new water. It is water that has already been ocean and cloud and rain more times than any record could count, returning now to do the same thing it has always done, because that is, in the most basic sense, all water on this planet has ever known how to do. This means that the water sitting in the glass beside you, wherever you happen to be lying tonight, carries within it a history stretching back further than almost anything else you could reasonably hold in your own body. Some small portion of those molecules, statistically speaking, likely passed through the body of some living thing that existed millions of years before you were born. Some portion may have rested, at some point, inside a glacier that melted away long before anything resembling a human being ever stood upright to look at it. Some portion may have fallen as rain onto ground that has long since eroded into some entirely different landscape, unrecognizable now from whatever it once was. The water does not remember any of this, of course. It carries no trace of where it has been, no memory of the forms it has taken. But the story is there, all the same, folded into the simple, ordinary fact of its presence beside you tonight, whether you ever think to notice it or not. Consider, for a moment, the particular water inside your own body as you lie here. It arrived there through an unremarkable, everyday process. Water you drank at some point today, water contained within whatever food you ate, absorbed quietly into your system without any conscious thought on your part. And yet that water, however ordinary its arrival, is made of the exact same substance we've followed across this entire story, present in your body for the same essential reasons every living thing has depended on water since that first quiet stirring in an ancient shallow sea. It is helping to hold your cells in their proper shape right now, providing the same kind of gentle internal pressure that once gave shape to the very first living structures to ever exist. It is carrying oxygen through your blood, delivering it to wherever your body currently needs it, following the same basic principle of transport that water has provided to every living thing across the entire span of life's existence. It is regulating your temperature as you lie there, quietly keeping you within the narrow range your body requires, doing precisely what water has always done for every creature that has ever depended on it to survive changes in the world around them. None of this asks anything of your attention. It happens whether you think about it or not. The same way the ocean continues evaporating, whether anyone happens to be watching. The same way a glacier continues its slow, imperceptible movement, whether anyone stands nearby to notice. Water simply does what water has always done, inside you tonight, exactly as it has done inside every living thing before you, all the way back to whatever first fragile chemistry managed to hold itself together in that early sea. Somewhere outside, wherever you are tonight, water is continuing its work in every form we followed across this story, all at once, without pause. An ocean somewhere is evaporating quietly under whatever sky currently stretches above it, sending vapor upward to feed the clouds that will eventually deliver rain to some coastline or some distant inland valley. A glacier somewhere, high in mountains you may never visit, is inching forward by some fraction of its own length, exactly as it has done every day for longer than anyone could easily calculate. An aquifer somewhere, deep beneath ground that looks, from above, like nothing more than an ordinary field or forest floor, is holding water that fell as rain long before you were born, resting in darkness, waiting for whatever slow combination of pressure and time will eventually return it to the surface. And somewhere, right now, a single drop of rain is falling, landing on ground it has never touched before, joining whatever river or lake or ocean happens to lie downhill from wherever it lands, continuing a journey that began, in the truest sense, billions of years ago, in fire and in ice, on a planet that once had no water on it at all. This is not a story that ended somewhere back in the deep past, safely finished, tucked away behind you. It is happening right now, in every direction, at every scale, continuing exactly as it has continued since it first began. Let the whole story settle now, the way a river settles when it finally reaches flat ground, spreading wide, slowing, losing the urgency it carried further upstream. A young, dry planet, glowing orange in the dark of newly formed space, holding no water anywhere on its cracked and restless surface. Water rising from deep within that same planet, released slowly through fire, through volcanic vents breathing vapor into a thickening sky. Water arriving from somewhere else entirely, carried across an unthinkable distance by comets and asteroids formed in the cold, distant reaches of a young solar system, delivered to this world through impact after impact, spread across a stretch of time too vast to hold in any single thought. Rain, falling without pause, for longer than anything alive today could patiently endure, filling the lowest places on a newly hardened surface until they became, for the first time, an ocean. That ocean growing salty, slowly, as rivers carried dissolved minerals down from the land surrounding it. Evaporation beginning, and with it, the water cycle, still turning today exactly as it began turning then, rain and cloud and river, without interruption, across the entire history of this planet since. Water sinking into rock, resting in the dark for centuries or millennia, patient in a way nothing else in this story quite manages to be. Water rising instead toward the coldest parts of the world, gathering as snow, compressing slowly into ice, moving by fractions of an inch across stretches of time too long to properly imagine, holding within its structure a record of the very air that existed the moment it first fell. And water, finally, making life itself possible. Present in that first quiet stirring in an ancient shallow sea, and present still in exactly the same essential way in every living thing that has ever existed since, including you, lying here now, made in some real and literal sense of the very same water this whole story has been following since the beginning. The volcano is still breathing somewhere tonight, releasing its own small trace of water into a sky that has been receiving it for billions of years. The comet's ancient legacy is still here too, folded into every ocean, every raindrop, every glass of water resting quietly on a table somewhere in the dark. The first rain has never really stopped. It simply spread itself out across the whole of Earth's history, falling now in countless separate storms rather than one continuous deluge, but still, in its essential nature, the same rain that once filled an empty world. The ocean is still filling itself, drop by drop, exactly as it always has. The aquifer is still holding its water in stillness, somewhere far beneath whatever ground you might be standing on tomorrow. The glacier is still moving, by fractions of an inch, carrying its ancient trapped air forward into whatever future awaits it. And the water inside you, tonight, holding you together, carrying what you need to wherever it's needed, resting quietly within you the way it has rested within every living thing before you, is the same water. The very same water, older than any mountain, older than any ocean basin, present on this planet since before the planet was entirely finished becoming itself. It has been falling and rising and resting and moving for longer than anything else you could name. And tonight, for a little while, it is here with you, holding still. Good night. Sleep well.